tracking a topic that is increasingly important in our tech-driven world, the environmental impact of our work. I'm excited to introduce Aicha, who will be presenting on Java and Kubernetes in the service of the environment. Did you know what the tech industry carbon emission reveals that of the entire aviation industry? So it's a surprising statistic, and Aisha will be shedding light on how our code plays a part in this. In her sessions, she'll be showing us how to build greener Java applications exactly with Kubernetes without compromising performance. Please give a warm welcome to Aisha. I stopped sharing, so please share your screen and you are welcome with so exciting topic.
Thank you. Thank you, everyone. I'll start to share my screen. I need to look. Where is it? Where is it? Okay, yeah, I found it now. Okay, so hello everyone, and thank you all for joining my talk about Java and Kubernetes and the service of the environment. But before we talk about this, let me introduce myself. My name is Aicha Laafia. I'm a Java software engineer at Havana Group, currently working with CFTP, which is a legal protection insurance company operating in France, Luxembourg, and Belgium. So in my role, I focus on backend development, solution designing, and some DevOps like tasks from time to time, always trying to implement some greener practices and so on. Originally, I'm from Morocco and now living in France. And beside my work, I'm passionate about green programming, obviously, and sustainability. I also contribute like into communities such as Women Techmakers and Girls Code. I'm ambassador in both of them. And as I love sharing my knowledge, I'm also JetBrain community contributor and member of the Moroccan Association for Computing Science. And for fun fact about me, outside of coding, I'm a Formula One fan and a foodie lover. So let's start right now with the most important question is why sustainability matters in software development. Why am I doing this talk? Well, if you ever thought about how many energy your code consumes, or just you got this idea, because we often think of software as something intangible, just bits and bytes running on the background, when in reality, every inefficient line of code has a real impact on the world. For example, did you know that the tech industry consumes 7% of the global electricity and it's only growing? Like data centers alone accounts for 2% of the world total energy demands. That's more than some entire countries. Blockchains too, like it consumes more energy than entire Argentina energy consumption. And that's the real impact of our code has on the planet. And this is why sustainability matters. And we're not only talking about electricity, but also carbon emission, because unfortunately our tech industry contributes to 4% of the global greenhouse gas emissions. And if you think 4% is a small amount, it's more than the entire airline industry carbon emission. But sometimes when we talk about big numbers, but how can this affect our daily lives? Well, I have bad news for streaming like fans who like to binge watch, especially binge watching their series on the weekend. If you only watch your favorite series for 1 hour, you stream it, you produce almost 55 gram to 100 gram of CO2. That's only per one user. If you can imagine how scary the number will be if you multiply this by millions of users. And as and we'll talk about some simple tasks we all do during our pro like daily. We send emails, but if every one of us sent like we can't say 20 emails per a day per year, that's equivalent to driving 100 or 1,000 kilometers. Sorry. So now imagine the impact of inefficient like application running at scale. How much like carbon footprint it produces, how much electricity it consumes. And this is why optimizing our code is not just about performance, it's about sustainability. And now it's time to introduce green programming. So what is green programming? What's the first thing or idea or keywords that's come in your mind? If you are thinking about like recycling, reducing waste, optimizing, if those words come in your mind, you are right, because green programming involves developing software with the focus on energy efficiency. Now, and sustainability, it means writing code that use less power, optimizing our application to run more efficiently, and always considering the environmental impact of our software choices or development choices. And now, since I'm talking about Java, the big question is what you can do about this. I'll try to showcase to you some Java like strategies for green Java development, but the good thing is that it could be implemented so easily or be approached or approximated, not like approach to implement this on other programming language. And for like Java, the first or the most important area we need to start with, and its most impacted one, is the GVM. And from the meme, you can tell the first thing we need to pay attention to it is the garbage collection, because GC or the garbage collection, it's not just about memory management because it directly impacts the CPU load, latency, and energy consumption. And in the world of the green Java, we want to minimize those impacts as much as possible. First step we start with is choosing the right garbage collection. And now the question you might ask yourself, which one we should use? It depending on your use case. If you're really like beginner, you don't know what to choose, you don't know even like it's really relevant or not, we have the G1GC, the default choices for a reason, because it's balanced for large heap, keeping POSIX time low. And if you are already running Java 21 in your production or your application, you don't need to do anything, it's already there by default. And if you want something more fancier than G1GC, we have the ZGC. It's the best for real-time application where we cannot afford low POSIX. And we have Shenandoah, which is my favorite one. It's great for a scalable application. And why I really like it, because it doesn't care about how much your memory size, whatever it's 2 gigabytes to 2 megabytes, it's always making the work done without complaining. And if you don't care about like how much your POSIX time will be longer, you're only looking for more high throughput, you can use parallel GC. For example, if you are working with batches jobs, it's perfect for this. And if you want only to test benchmarking, not like real software development or a real application that has a high traffic and so on, you can use Epsilon GC. The thing about it, it's no operation garbage collection. And please, please, please don't use it for the production. All your application will shut down and you will kicked up like this guy here. So this is why choosing the right garbage collection can have a real impact on energy efficiency, like by reducing the CPU overheat and avoiding unnecessary like computations. But what if our application is still slow? Like, what if we're experiencing some unexpected garbage collection pauses? And this is where the collection tuning comes in. And that's what exactly we'll see on the next example. Like right now here, we try to create 1 million transaction in parallel. Each transaction has a random amount in the unique ID, and we will track like execution time to measure performance. This might look simple, but right now the garbage collection are dealing with 1 million objects. Let's see how long it takes for execution. Boom. Well, it takes over like 20 seconds to process this transaction. And this is way too slow, right? And now let's investigate. Could the garbage collection be the issue? Especially right now, we are talking about cleaning 1 million, like 1 million objects. Good thing for us, Java developer, because Java already provides built-in GC login, which can help us to see what's happening under the hood. How, like, for example, how often the garbage collection runs and how long it takes. And to do this, we will simply execute our program with a command to enable the garbage collection logs. And we're talking about this, like minus x logs. We have the GC asterisk. Like this is where we tell our, like when we run our application, but to showcase to us all the logs for all the garbage collection events to also to check the POSIX time. And we have this one, the minus xmx2g in the minus xms2g. It's for to save the heap size to 2 gigabytes fixed to prevent dynamic exception. And when we run our command and execute our code, we will get some logs like this. In it, that's too much like to read is all during the talk. To recap, we have this. We have we have like 3 garbage collections running with like their G1 GC. As you can see, G1 evacuation here. It's the type. And for the POSIX times, it take over between 170.4 400 millisecond until like 322.169 millisecond. So we are using G1. It's a good choice, but still, like POSIX time, it's still taking over like approximately average between 200 millisecond. That means significantly slowing us down in every time we're trying to process this transaction. So we confirm the issue is in the garbage collection. How we can fix that? This is where like we do the tuning garbage collection. It's all about tweaking some GVM options. For example, we have the minus xmx like max GC POSIX minutes. We put it to 50 to reduce the target POSIX time. We have the minus xmx G1 heap region size to 8 M. It's to optimize like memory region size to like 8 memories. And we have the minus xmx initiating heap occupation percent. We put it to 30% to so we can trigger like the GC earlier to prevent long pauses. And we have the minus xmx G1 mixed GC counts target. We put it to 8 to limit the mixed GC events for a better like efficiency. So, and we have always the minus xmx and minus xms 2g. So we can to set the heap size to 2 gigabytes. When you run it, this is like what we got. The execution time dropped from 20.50 29 millisecond to like 20, we can say it's 20 seconds, sorry, to almost like 12.72, like approximately seconds. And this is what garbage collection is all about. Like tuning garbage collection is all about. We're talking about reducing pauses, improving stability, and optimizing memory instead of just like leaving the GVM's default setting and wasting much energy and time, letting like within we did with all the POSIX time we had previously. But garbage collection tuning isn't enough. Sometimes it could be like not only the memory but the memory execution itself slowing us down. And this is where the just-in-time compilation to the rescue. So instead of execution method every time, just-in-time compilation, like it selects the most frequently used method and it's compiled directly at the runtime. That means faster execution, less CPU overhead, and lower memory usage. So, and what just-in-time compilation do? They have some techniques or key optimization they implement, such as inlining, where just-in-time compilation replaces method calls with direct code execution. That means cutting method lookup times instead of just going like that method lookup time. It's the method we spend on in and out of the method every time we call it. And we have the escape analyze where we just in time helps avoid like unnecessary heap allocation. And finally, there is the loop enrolling, where sometimes like we don't have to go through all the loop and just in time detect this. So it reduces the number of loops iteration, making the CPU cycle more efficient. So for since the Formula One season start now, and as I said, I'm a Formula One fan. If you are already a fan or familiar with the term, you can think of just in time as a Formula One pit crew. Like, but like it's constantly fine tuning the car in real time, like in the race to maximize speed on the track. So instead of just waiting for the pit to replace like something needed there, they replace it on the race. It's impossible in real life, but just you can think of just in time like this. So now let's focus or let's see some one of the just in time smartest trick, which is escape analyze. Because sometimes we don't see them, we don't think about them, but some objects get stored in memory even when they don't need to be there. For example, we are running like here 1 million transaction, meaning any inefficiency gets magnified by 1 million times. At first glance, it looked like a great concurrent solution. Every transaction created a new object on the heap, which means right now we are forcing the garbage collection to clean up 1 million objects consistently. So when we run our code, we will get like 5.7 approximately second execution time, and that's kind of slow. Well, so now how we do fix this? Let's optimize our allocation. So let's see here how we can element heap allocation to speed up execution. So before optimization, like each transaction has a string here, and that's what forced like our transaction to be heap allocated. That means every transaction objects trigger GC cycle, slowing things down, and so on. How to fix this? Simply, we can like eliminate we can eliminate or remove the string here, keeping only like the primitive types int and double. And now we have just in time compilation to place the transaction on the stack. So that means no garbage collection needed. And also as a bonus, right before we were like working with the virtual treat executor. Virtual tree has been introduced in Java 21. For the one who's not familiar with it, it helped us especially to deal with something we were really struggling with, which is the multi-threading in Java. But the cost is that the virtual tree has a long wait or like waiting time. And it's a good thing if you are running multi services, but not for a simple method, simple class, or even monolithic when you or some, especially if you are dealing with the calculation or mathematic operations. Please avoid using virtual trees because you will waste many time waiting for that and so on. And to help with, you can use what you call structured concurrency. Like it will improve concurrency and will reduce wasting time and overhead too. As a result, the execution time dropped from 5.7 second to like 1 point, approximately to like 1.73 seconds. That's 3 times faster, which means also like less memory pressure, lower CPU usage, and more sustainable Java application. And that's how we could say we unlock performance gain with a smarter, greener memory management. As you can say, but when we let's talk about our second strategy, which is the analyzing resource usage. Why? Because even the fastest code can be wasteful if it's burned through resources unnecessary. Like if you want greener, more efficient Java application, we need to measure and analyze where our resources are going. Otherwise, we will end up only optimizing in the dark. So let's start When we analyze the resource usage, we focus on three main keys. We have monitoring, identifying resource intensive operation, and using advanced tools for more deeper insights. So to optimize efficiency, first we need visibility into what's happening at runtime, like how much CPU in memory is our application using. Are there memory leaks? Is, for example, the garbage collection adding unnecessary overhead? So for this, and to answer or have more clarity, or we can call it visibility, we use tools like the G console, Visual VM, Java Mission Controller. Like these help us monitor performance at real time and catch potential bottlenecks before they impact the users. Also, something we need to keep in mind, not all operations are equal. Some are CPU heavy, some stress memory, and some drain power. So how we can pinpoint those hungry operations? Well, this is where we can use, for the Java like developer, they use Java macro branch harness (JMH) to analyze and to measure just-in-time optimization, because with this tool we can isolate specific method and measure their impact instead just of guessing and wasting time. Like we we guess that maybe it's method X, we try to analyze it or measure how much CPU it drained, and it turned out that it's wrong. So right now we're wasting time, resources, and so on. And instead of just using GMH, that will get us where our resources are being drained. Like we get precise benchmarks that tell us where we need to optimize. Also, if you want to go for deeper insights, especially into memory and garbage collection behavior, we will need to go beyond the basic monitoring. Tools like gprofiler, ukit, and Eclipse MIT, if you are using Eclipse, allow us to analyze heap dumps, identifying memory leaks, and of course fine-tune the garbage collection strategies. And if we care about energy efficiency, because hello, our tech industry consumes 7% of the global electricity. Mac OS, and especially for the Mac OS user, they already provide what we call power metrics. It's a tool that measures the actual power consumption, helping us optimize not just for the speed, but also for sustainability. And now that we know how to measure resource usage, it's time to put one of these action and one of these concepts into actions, with some real world example. I choose to talk about energy because we mainly focus when we talk about monitoring about memory, energy, not energy but memory, the CPU load, and so on. But we forgot mostly about energy, and that's a bad approach because as I said before, our tech industry is really draining energy, and especially right now with all the AI revolution that's happening. It's more scaling up our energy resources. I advise you to check for how much energy one prompt need to consume. So now let's go back to our talk. As we said, when we optimizing the CPU, energy, memory, input output, but what about energy power? High performance code is not always energy efficient, but power consumption is a crucial factor in reprogramming. And if you want to measure real power usage on Mac OS, we use the power matrix here. It's really simple. We call this command. So the power matrix minus minus samples, CPU power minus I, 100 minus n 10. That means like we tell our Mac OS to track the CPU power over 10 seconds, because here it's minus I 100 milliseconds, and the number of samples it's 10. That's why 1 second point multiplied by 10, it's 10 seconds. So it captures the CPU power consumption every second, helping us analyze energy usage in different scenarios. And if you want to transfer your like the results of this command to like our energy usage, it's simple formula like you get the result, the power in watt that you get, the CPU power multiplied by how many hours your code has been running. Let's run our code. I already like I try to run our code on two different scenarios. First thing is my new greener code that I've been already optimized. It does the same thing as like the second one here, the old one. But when I try to measure how many energy it consumes, as you can see, like the idle state, we have it's not our greener state, the CPU power consumption, it's 1.53 watts, and loaded all the not greener state, the CPU power consumption is 3.76 watt. And when we multiply this by 1 hour, like our code's been running for 1 hour, we get like the greener, it's 1.53 watt hour, and the not greener, the older, is 3.76 watt hour. The impact, as you can see, that inefficient code increase power consumption drastically. Right now, we're talking about aspects of 136%, like if we compare it with like the greener one. And this is why like optimizing the CPU usage not only improves performance but also reduce energy waste. It's a win for both efficiency and sustainability, and also like economically. When we reduce energy, we reduce cost because come on, we pay for electricity bills. So we get to economic some dollars or euros when we optimize our codes too. And imagine like this this small merge being multiplied by million of times that our code been called, million of users, we will economic a real like numbers. And that's like this is why I love to always make sure to tell stakeholders that green programming is it will bring benefits for them too on the long term. And now that when we measured our like energy or resource usage that our application uh, use every time it's run, it's time to reduce it. Because optimizing Java application is not just about the speed. It's about reducing resource usage and making our software greener. And to achieve that, we focus on three areas. We have the memory management, we have the input-output operation, and we have the reducing idle time. So let's break them down. Well, first let's talk about memory because excessive memory leads to like unnecessary CPU cycle and the wasted energy. Let's start with some simple examples. I try always to choose the simple one that the non-Java developer could get idea from it and implement it in their way. So, for example, we have array list versus linked list. Please try to use array list for random access to avoid all like the linked list pointer overhead, especially linked list if you not familiar with it, if you want to go from like if you want to go for a number that is on the fifth order, you have to pass from the first, the second, the third until the fifth. So right now you're wasting time and resources. Instead of like array list, you want you will only have to go through directly to your elements and get the value from it. Also, like when we talk about strings, try to use string builder instead of the traditional like plus operation or string concatenation, because for example we'll try to create a string by adding 1 million, like 1 million character. The issue about string, they are immutable objects. Every time we add something to it, we are creating a new object. And if we add 1 million character, we are creating 1 million objects. That doesn't show in our code, but garbage collection is already suffering enough with it. So uh, instead of creating 1 million objects and letting the garbage collection deal with it, we use the string builder, which is a mutable object. Every time we add a new character to it, it's like it remains the same object. In the garbage collection, I have to deal by the end by cleaning only one object here. So we move to concurrent hash map here, like it's for treat save operation. It performs better than the asynchronized map, especially like avoiding all unnecessary waiting time and so on. So memory optimization reduce the GC pressure, the CPU usage, and energy waste. But memory is not the only culprit because the heavy input-output operation can drain power too. How to fix this? Well, you can use like the buffered input-output streams and asynchronized input-output operation to reduce the blocking and the waiting time. That's the main issue we have on the trading because the traditional streams block trades, but the NIO buffer in channel reduced waiting time. Also, instead of just waiting for file operation, we let them execute on the background, and we have what we call the completable feature that could help execute multiple input-output tasks in parallel without keeping the CPU thread idle. Like we don't have to wait for a task to be done, then to go through the next. It's being done in parallel on the same time. And by this, like reducing input-output bottlenecks, making our application run faster and more energy efficient. But sometimes, even when our application is not actively working, it can still waste the CPU cycle. And that's where we talk about the idle time. And how to fix this? This is where we need to introduce techniques like thread pooling to manage resource efficiently, like you can implement fork join pool. I love like to work with it because it distributes work across available CPU cores efficiently, reducing like wasted time or wasted cycle too. We have the structured concurrency. I already talked about it. It prevents unnecessary thread waiting in keeping the execution streamlined. And please, something that when we've been introduced to recursive calls, no one told us about deep recursion, and we need to avoid this. We need to restrict logic to minimize redundant computations and always optimize our recursive calls. And now, by optimizing memory, input output, idle time, we reduce power consumption, improve performance, and make our Java application more sustainable. And now we will talk about the last Java like green strategy and the most important one, which is choosing the right algorithms. Because we could tell that algorithms are the core for the green programming, because algorithms define how efficiently we process data, how we search for information, or compress files. And a bad choice can lead to a bottlenecks, high CPU usage, and wasting energy. But the main challenge that we faced or we have, because it's not just about the speed, it's about finding the right balance between performance and sustainability. As we mentioned before, even the fastest algorithm can be wasteful if it's drained many resources. So, for example, like I'll try to show you some real life example that I've been seeing many teams do this mistake. Like we're talking about sorting massive datasets in real-time analytics, and one of the team use quick sort because it's quick. It's the best choice, but here is the issue. Quick sorts performs unnecessary swaps in comparison when the data, for example, we have a dataset that's nearly sorted. That means if we are talking about like 1 million objects, that's only 10 objects, they're not sorted, and quicksort will have to go through all that 1 million, and you are wasting time, like wasting energy, and you are causing the CPU spikes. The solution, this is where we need to switch to time sort. I love time sort because it detects nearly sorted datasets and optimize sorting dynamically, reducing the CPU like cycles and always reducing access overheat, like memory access overheat. Because, for example, it could detect easily that we have only 10 million in 10 million objects. We have 10 or, for example, 5 objects that's not sorted, and they switch and compares all that to make it in the right order. And as a result, like we have fewer computational, lower power consumption, and much greener algorithms. And this small switch can make a huge difference. So, for example, like we have our code on the like the quick sort, it's give us execution time is 43 millisecond, and the time sort it's 27 millisecond. And now you can see like it's simple thing that we can change can have a real impact. And always, if you think that these numbers are small, like the small difference between them, try to multiply this by how many users you have: 100,000, 1,000,000, 10 million, and so on. Then you can see the real difference. Like with these tools, with these, like when we choose the right garbage collection, and we implement the right we tuned our garbage collection after choosing the right one. We like monitor and analyze resource usage and reduce that, and then we choose the right algorithms. Right now, like we ensure that our application run like a smooth operator, green operator, all while having some fun. Well, when you get to know that your application are having a few environmental impacts. But it's not just about the cloud, or it's not just about Java, it's about the cloud too, because preferring cloud-based solution can also contribute to green programming, especially because cloud providers often operate energy efficient data centers and offer scalable resources that can be managed more efficiently than the traditional one. Right now, if you could like just a small research, and you'll find how many efforts, especially like the famous cloud providers. We're talking about cloud, Google Cloud. Like right now, they are trying to run more you can say friendly ecosystem, and especially like renewable, using renewable energy for the data centers. And Google Cloud, they say that they try by 2030 to go for a data center that run with zero carbon emission. Uh, AWS, they claim they are the greenest like cloud providers, and they are doing a lot of effort, especially with the carbon emission. They're reducing a lot of that, using some energy waste, and also like they're trying not only to go for what we call like renewable energy, but to reduce the impact of it. Because when we there is some heightened impact. For example, we have rising the temperature of the ocean. They are trying to implement more algorithms for cooling that and so on. So they are doing efforts, and that's why we need to salute them for this. Because before, even when we use cloud, that was not enough because we are running on the server that's been using energy, electricity, and so on. So we were still on the same dilemma. And right now, because as we said before, when we use more cloud resources that could be more like managed and more efficiently than the traditional one, this could lead to significant cost and energy saving for your application. And what's a better way than using Kubernetes for resource management? Because once we moved our Java application to the cloud, efficient resource management become crucial for both performance and sustainability. And this is where Kubernetes shines with the autoscaling, especially with the horizontal pod autoscaler HPA, because HPA, like it's dynamically scale up number of pods when the traffic spikes and scale down during the quieter time. And this flexibility like help ensuring we are not over provisioning resources and wasting energy during the off-peak times or season. So we can think of this elastic work like workforce as we are having a factory, like we more workers or pod are being called in when we need it or sent home when things are slowing down, ensuring that the application run efficiently. But managing like scalability doesn't stop at adding more pods, but we need to ensure that each pod had is using like the resources efficiently, which is where the vertical pod autoscalers come in. And now let's explore how the like VPA works to optimize resource usage at the level. It's kind of the same thing as like the HPA, but the difference is that the VPA adjusts the CPU and the memory allocated to individual pods, ensuring each one has just the right amount of resources. And this is prevent under provisioning, like where pod might struggle with a few resources, and over provisioning where it consumes more than the necessary like resources needed. So think of like HPA as increasing the number of workers during the high demands, and well, VPA is about giving each worker the exact tools they need to do the job effectively. So HPA adds nodes when needed, while VPA optimize resources within each node. So together they create a system that's both scalable and efficient. So we ensure that our cloud environments run smoother without wasting energy. And here is one simple rule I really like to say this in every talk I give is reduce, reuse, recycle your container. Because in the last like few decades, we always talking about recycling our garbage, the real one. And it's time right now to talk about the virtual one too. And especially for the Java developer, we're not only talking about the garbage collector, we don't let them do all the work. We need to recycle our garbage collection, our virtual garbage too, whenever we're talking about code or about like clusters, containers, pods, and so on. So by optimizing like resource usage within each pod, we are reducing waste, reusing resources effectively, and ensuring that every container plays its part in minimizing our environmental footprint. And please, let's stop about doing the backup for the backup. Like we have a backup cluster for a backup. We need to stop this because not all the time this kind of scenario happened, and we will end up always like wasting much resources on running like a cluster that will be used if it's been used maximally once or twice like in a year. And finally, it's time to we need to to you can say scale up our game, our cloud game. This is where we need to define the resource limits and requests for our pods to make sure that we are allocating resource effectively without risking over provisioning. So like to ensure efficient use of resources, we need to set resource requests and limits for our pods. Requests we mean by to set the minimum resources each pod needed, with limits it's to cap the maximum they can use. It's like giving worker enough tools to do their job, but making sure that no one takes more than their fair share. Like if you can understand how it's work. So by defining like these parameters properly, we can prevent the resource hogging, where one pod consumes more than needed, potentially cause issues for others. So to recap, like by using autoscaling, resource allocation strategies, proper resource limits, we can create Kubernetes environment that's both efficient and eco-friendly. And like so, when we have our when we implement the greener, sorry, it's the cat. So when we implement like our Java optimization techniques and we allocated and containerized these Java apps with the all like with having the right autoscaler, we're implementing HPA, VPA, we are right now like hitting the sweet spot of sustainability. Like Kubernetes give us the flexibility and scalability for for resource management. We set limits for it. We deal with it, and it's time like to see some like to measure the real impact of all these efforts of Kubernetes and Java together. Because like measuring in monitor, this is where we need to adjust or to level up our measuring and monitoring tool, or even like try to implement them if we're not using them before, because they are crucial to measure the impact of our optimization effort. They could provide some insights into application performance, resource usage, and helping track energy consumption and environmental impacts. And now I'm not talking about this one here, but more of this one. Like we have the Green Software Foundation Carbon Aware Sticky, a tool that could help software developers to create carbon aware application. We have Dynatrace that provides AI powered monitoring application performance and resource usage with a very cool dashboard. I really like their dashboard. It's really simple. You could find anything you want to analyze or to profile there, and especially with the metrics, it could like recap all the numbers without having to read through all that logs. And something that we're familiar with, which is Prometheus in Grafana, that's our open source monitoring solution that could be used to track application metrics and always visualize data, because the more our data being visualized, it's more easier for us to be accessible for them. Also, we have OpenTelemetry and other Scientia products that we could use. For example, we have the Cube State Matrix, which that this tool like provides detailed metrics on the state of Kubernetes object like pods, nodes, and deployments. It's a great way to keep track of cluster health. We have the Zyger. It's a distributed tracing tool that helps you monitor requests across the service and the microservices. Like this is a particular useful for identifying bottlenecks in complexity, especially in the in a complex multi-services applications. And also we have what we call KEDA, which is a Kubernetes event-driven autoscale. Like it's a Kubernetes event-driven autoscaling that allows you to scale application based on the custom metrics such as messages in the queue, or even external metrics like web traffic. If you This is when you want to really like level up your like autoscaling game. And there are many others like Fluented if you are more like log people, because as a developer there are two types. There are the one who prefer visualizing in metrics and the one who prefer logs. We have Fluented, which is an open source log aggregator that helps you collect and parse along with routing like log data from your applications. And now there are others like Scientia for any other open source tool that you can use to keep track of not only like energy but also the carbon emissions. And now let's take some real look at some real examples where green Java developments been produced. What? Sorry, stop. Uh, this is where we'll try to showcase the real like impacts that's been seen by some companies who implemented the real like green Java development. Our first like project is, or our first startup or company right now, because right it's really doing big. It's the Green Tech Software Solutions, a company focused on energy efficiency software for environmental monitoring, like by optimizing algorithms to reduce computational complexity and always preferring cloud-based solution for scalable resource management, they like as a result they cut energy consumption by 30% and lowered their carbon like food carbon emissions significantly. That's a real like and a great example of how smart coding choice can directly impact sustainability. So here is a fun fact, or here is their real win. Green tech software solutions saved enough energy through their optimization to power 200 homes or houses for 1 year. This is something we need to celebrate. This is we need to say thank you to them and get inspired to do the same. Like this illustrates the significant impact that green programming can have on energy conservation. Our second and last example is Monzo. Monzo Bank is leading the way in sustainable digital banking, like by optimizing their Java microservices and leveraging Kubernetes for efficient container orchestration. They cut idle resources consumption and they enhance their system like efficiently. This shift to sustainable focused cloud infrastructure results in a 35 reduction in energy usage and a lower carbon footprint. And beyond technology, this is for me the real win. Monzo actively engaged 500,000 customers in sustainable initiatives, building a community of environmentally consequences banking. So get inspired. Today we learned from this case that we can identify several common techniques that contribute to their success. This includes optimizing server usage, selecting efficient algorithms, and using renewable energy resources. Well, that was not like something easy to implement. There were some challenges along the way, such as balancing performance and sustainability. These projects demonstrate that it's possible to achieve significant environmental benefits through green programming. And it's time for action. Start small. Implement green programming like incrementally. Remember, baby steps are better than zero steps. Also, you need to educate and advocate. Raise awareness within your team, stakeholders, family, friends, community. A greener code base lowers cost and boosts efficiently, so it's everyone's win. And like the environmental and like your budget will thank you if you implement green like practices. And also remember, optimize and monitor, apply best practices and track progress to ensure continuous improvements. And finally, join the movement. Contribute to sustainability initiative. If you are using, for example, CNCF production, check out the Tag Environments Green Review group to make an impact. Like there is also green IO events, and I've been seeing like they've been adding tracks on different events about sustainability. Go check those talks. Maybe you can even like watch them online if they are available to see or to know some tracks, because green programming, the heart of it is how to start, how to know or where you need to know when to implement it, where to implement it, how to implement this, and talks in articles talking about sustainable always providing like the resource you need for this. Because we can resume this by teams work make the green work. And now we have covered a lot on the ground, but let's wrap all we said in three tips. Code like a tree, deep roots, efficient branches, and always remember to reduce, reuse, recycle your container. And always when you code, you have to know that every line of code is a vote for a greener future. And as a result, or here is the last fun fact, if every Java developer optimized their code for energy efficiency, we could reduce global energy consumption by equivalent of removing between 20.7 to 30.8 million cars per year from the road. And if you think I'm just exaggerating, well, because normally, like data center energy use, we consider the global data center consume hundreds of terawatts annually, and even at the, like 10 if we only reduced 10% of it, it could save between 20 to 30, 24 to 34 terawatts. That's equivalent to the consumption of 20.7 to 30.8 million cars from the road. And now, thank you all for your attention and participating today. And I hope you find my talk more informative and inspiring. So let's make our code cleaner and the planet greener. Thank you all. Also, if you want, you might share your feedback here. And if you want to read more, I already been writing articles about this. You can find it on Medium. You can reach out to me via Twitter or LinkedIn. I'm more than welcome to provide you with all the necessary knowledge you will have to start your green like journey.